This video is problem 49 of our problem set, and if anybody not from my class is watching, this is the final exam of May 2018. The statement of the problem is there in black. You can pause the video and read it. And we are given demand and supply, and we have to find the price function and study the behavior when t goes to infinity. As we don't have any other information, natural thing is demand equals to supply. So we have, let me remove the parentheses with the t's, plus 3p double prime equals to minus 8 plus 4p minus 5p prime plus 5p double prime. What we're going to do now is put everything that has p on one side, so all this moves to this side, and be careful, you have to change the signs, that's very important, and whatever is here goes to the side, also change signs. So we do this computation, and on the left hand side we have 16 minus and then minus 8. First minus because it moved to the other side, so this is equals to 24. On the other side we have this thing here and minus 3p double prime, so it's 2, and then minus 5 minus another 5 is minus 10, and then 4 minus minus 4 is plus 4, so plus 8p. So our equation is 2p double prime minus 10p prime plus 8p equals to 24. Everything is divisible by 2, so we actually simplify this to the form p double prime minus 5p prime plus 4p equals to 12. To solve this equation, we do our usual steps. So our step 1 is the homogeneous equation. So the homogeneous equation is p double prime minus 5p prime plus 4p equals to 0. Is degree 2 because it has a double derivative. So we build the characteristic equation lambda squared minus 5 lambda plus 4 equals to 0. And here lambda equals to minus b plus minus square root of b squared minus 4 times 4 is 16 divided by 2. Now 25 minus 16 is 9 and root 9 is 3. So this is 5 plus minus 3 divided by 2. And we have 5 plus 3 over 2, which is 8 over 2. And 5 minus 3 over 2, which is 2 over 2. So our homogeneous equation is, this guy gives us e to the 4t, and this guy is e to the 1t, e to the t. So will be a constant e to the 4t plus another constant e to the t. Once we have that, we go for the particular solution. The particular is a solution that solves the problem, but it may not satisfy our initial conditions. That doesn't matter. What we have to do, remember, is write 12 as a polynomial in t times e to the mu t. Here, the polynomial in t is 12, which is a polynomial of degree 0. E to the mu t, you don't see here actually because you see 12, but 12 is the same times 12 times e to the 0, because e to the 0 is 1. So when you don't see, you have mu equals to 1. And now you have to find mu equals to 0. And you have to find k. K, this is the number of times. This number 0 is a solution of the characteristic equation. Now, if you go back up there, your characteristic equation has solutions 4 and 1. The 0 is not here. Because it's not here, k is equals to 0. Okay? And now you build your particular solution as a polynomial of the same degree, which is a, e to the 0t, which is 1, and t to the k, t to the 0, which is 1. And your particular solution will be the product of these three. Will be a times 1 times 1, which is a. Okay, now we have the particular solution. Particular solution must satisfy the differential equation, which is up here. The particular solution has to satisfy that p particular double prime minus p particular prime plus 4p particular has to be 12. As we have computed, our particular solution is a constant, so the derivative of a constant is 0, and so is the second derivative. So this is 0 minus 0 plus 4a equals to 12, and a equals to 3. That leads to step 3. Step 3 is the solution. The solution for our problem is the homogeneous plus the particular, which is homogeneous C1 e to the 4t plus C2 e to the t, that's the homogeneous part, plus the particular, which is 3, that's the particular. And now we go back to, forward to step 4. Step 4 is using the initial conditions to find out these two constants that we don't know yet, C1 and C2. Okay, our initial conditions, you can look at the problem. It says that P of 0 is 100, that's easy, and it says it's decreasing at a rate of 1. So decreasing at a rate of 1 rate has to always remind you of derivative. So this saying that the rate is 1, but decreasing, so has to be negative. So we have the initial condition P of 0 is 100, and P prime of 0 is minus 1. For the P we have above, so P is equals to C1 e to the 4t plus C2 e to the t plus 3. P prime will be C1 e to the 4t times 4 plus C2 e to the t plus 0. So here we have P of 0 is equals to C1 e to the 0, which is 1, plus C2 plus 3, and this is 100. And P prime of 0 will be 4C1 plus C2, and that has to be equals to minus 1. So now we solve this system, which is simply C1 plus C2 equals to 97, and 4C1 plus C2 equals to minus 1. We take, for example, the second equation minus the first equation, because in that way we get rid of the C2. So that's 4C1 minus C1 equals to minus 1 minus 97. So 3C1 equals to minus 98, and C1 equals to minus 98 over 3. And from our first equation, we have that C2 is 97 minus C1, which is equals to 97 minus plus 98 over 3. So that's equals to 3 times 21, 2, 3 times 9, 27, and 2, 29, plus 98 over 3. So this is a 9, this is an 8, and 3 over 3. And therefore, the solution to our problem will be C1, which is here. This is C1 minus 98 over 3. This equal sign is very ugly. We'll remove it and we'll put it properly. E to the 4t plus C2, which is here. 389 over 3 e to the t plus 3. If you remember, here it is, for example, plus 3. What happens when t goes to infinity? Okay, when t goes to infinity, e to the 4t goes also to infinity, and e to the t goes to infinity. But e to the 4t, sorry, the t should be on the exponent. E to the 4t, you can think of this as e to the t to the 4. So this term is the fourth power of this term. So let me write here, e to the 4t is e to the t to the fourth power. So it's much more powerful. It's much bigger in terms. So from P of t, the leading term, the one that actually controls the side, the leading term is minus 98 over 3 e to the 4t. So this goes to minus 98 over 3 infinity, which is minus infinity. Like I said, the other part, which is this, goes to positive infinity, but this goes much faster to negative infinity. So P of t converges to negative infinity, which obviously has no economics meaning, because a price cannot be negative. So what happens at some moment, the first time it hits 0, the process stops.